Okay, we're going to be looking at problem number 3 on page 167. Good example on how to use some trig to figure out some other trig functions. So what you are given is that the tangent is equal to 1. Now the first thing is these trig functions, these are used with right triangles. So make sure I would sketch a right triangle, clearly a right angle here, and then theta can be either of the two angles, does not really matter. I'm going to go ahead and mark, I usually mark it as one of the angles down near the bottom, but it doesn't matter. You could draw the right triangle with the right angle on the right side. You could make theta the angle on top. In the end, it'll work out the same. Now, trig functions are usually set equal to fractions. So since this is just a 1, I want to make it a fraction. So 1 as a fraction, I can put 1 over 1. That would work for any whole number. If I had tangent of 2, it would be 2 over 1 and so on. So if it doesn't already equal a fraction, you can make a fraction by putting it over 1. And now I have to remember tangent. What sides of the triangle go with tangent? Well, SOHCAHTOA, tangent, TOA is opposite and adjacent. So in relation to theta, I need to label which side is which. This side here is my hypotenuse. The side that is opposite theta is the side that is across from theta. So this side is opposite and this side is adjacent. So now I know that my opposite is equal to 1 and my adjacent is equal to 1. And then before I go any further, I want to find my hypotenuse. So what we've done so far is we've used our tangent function to label the triangle. And you'll notice what we have now for number 3 looks a lot like what you started off with number 1 and 2. Basically, you had this extra part of the problem where you had to use a trig function to label a triangle, whereas on number 1 and 2, they started you with a triangle. Now, anytime you have two sides of a right triangle, you can find the third side using Pythagorean theorem. So just because we're talking about trig, don't forget you have Pythagorean theorem. So 1 squared plus 1 squared equals the hypotenuse squared, because a C has to be the side that's across from the right angle. In this case, the hypotenuse. I could have done a C squared, doesn't really matter. So 1 squared plus 1 squared is 2, is the hypotenuse squared. And then I find the hypotenuse by taking the square root of both sides. So the hypotenuse is square root of 2. Now, it could be some of you learned some special right triangles in math too, and you might have recognized that that was going to be square root of 2 without the Pythagorean theorem. If you did, taking that shortcut's fine, but if not, the Pythagorean theorem was there to help us out. Now, the directions said it wanted us to find the other trig functions. So I'm going to start with the basic 3. I had a tangent. And the next thing I'm going to worry about is sine. So sine of theta should be opposite over hypotenuse. And in this case, I already know my hypotenuse is opposite is 1. My hypotenuse is square root of 2. So sine would be 1 over square root of 2. We'll worry about rationalizing that in just a second. And then cosine is adjacent over hypotenuse. So adjacent over hypotenuse would be also 1 over the square root of 2, because the adjacent is also equal to 1. Now, that's my 3 basic trig functions. Now, you might remember when we were in class, we talked about you had 3 additional trig functions. They were called your reciprocal trig functions because you basically take the reciprocals. So the one that went with tangent is cotangent. We always put a co with one that did not have a co. So if tangent is 1 over 1, I'm going to flip it upside down, and cotangent will also be 1 over 1. So that's what I have for cotangent. Sine goes with cosecant because the one without a co, sine did not have a C, so it goes with the one with a C. So the S goes with the C there. Sine goes with cosecant, and I'm going to just flip it upside down. So that's going to be square root of 2 over 1. And then for the last one, I'm going to have to do it over to the side. The one that goes with cosine is secant. And secant of theta is going to be equal to the reciprocal again, which is square root of 2 over 1. So now I have all 6 of my functions. Now the one additional thing is we will need to reduce or rationalize our answers. So we're going to go back through each of those to see if we can reduce or rationalize. This first one, clearly for tangent of theta, I could simplify that to just be a 1. So your final answer for tangent is 1. For cotangent, it also has a final answer of 1. 1 divided by 1 is 1. For sine, I have a 1 over square root of 2. I don't really like the fact I have a square root of 2 on the bottom, so I can rationalize. The way to get rid of that square root of the 2 on bottom is multiply top and bottom by square root 2. So that's going to leave me with a square root of 2 on top. And then the square root of 2 times the square root of 2 is square root of 4, or just simplifies to 2. So 2 over square root of 2 for sine. Cosecant, I can just simplify it, and it's going to be just a square root of 2. Cosine is 1 over square root of 2, so once again I can multiply top and bottom by square root of 2. So that's going to give me square root of 2 over 2. And then secant, just divide by 1 will be a square root of 2. So that's the 6 trig functions in rationalized form. Sine and cosine, both square root of 2 over 2. Cosecant and secant, both just a square root of 2. And tangent and cotangent, both 1. Hope this helps. Please let me know if you have any additional questions.